Now we're going to turn our attention to writing the main program. That's the part of the code that calls the function. The first thing that we want to do in the main program is some fact finding. We want to get the end user to enter some information about how far they want to travel and how quickly they'll be traveling. Then in our main program, we should activate the function, the one that we just wrote, so that it actually carries out the calculation. We'll need to pass in the required argument information and, if necessary, capture the return value that comes back from the function. After we get the return value in the main code, then we'll be able to print it out, and that'll complete our program. Let's write the IPO chart for the main program's actions. I've already filled in the processing column for us. We just need to focus on what information are we expecting from user input, so what's the user going to type in, and then finally, what information should be displayed to the user. When we read through our example, it tells us that we need to do some fact finding, and the end user is going to enter information about how far they want to travel and how quickly they'll be traveling. So those are the bits of input: the distance and the time. And then it tells us that the program's going to calculate the speed, and then it will print the result. So the output that's displayed back to the user is going to be the speed. In our processing step, we're going to ask the user to enter the distance they traveled, ask them to enter the time they traveled. We'll call the calculate average speed function to compute the speed. We'll store the return value in a variable called result, and then we'll print that out so that the user can see it. Let's turn that into Python code now. We'll be adding this to the same file. This is up at the top. This is my function implementation or function definition. Those mean the same thing. If somebody's talking about a function implementation or a function definition, it means you're writing the code for your own function, and that always goes towards the top of the program. If somebody's talking about the main program, that's the part that calls the function. And in Python, that's the last component that goes into a program file. We'll write that in here. I'm going to move this over so we can see our processing column really well, so that can guide us as we're writing our individual steps in the main program. So the first step says we need to ask the user to enter the distance traveled. So I'm going to type that in: distance equals int input. Please enter the distance traveled. The next step says ask the user to enter the time traveled. Cool. Time equals int input. Enter the time traveled. Excellent. Now we want to call the average speed function. And it tells us that we're going to store the return value in a variable called result. So looking at my calculate average speed function, I can see it takes two different parameters here. So I'm going to need to pass in two arguments. And I'm going to have to make sure I get them in the right order. The first argument has to represent the time, and the second has to represent the distance. Python's not smart enough to match them up based on how you named them. So you have to be really careful when you call the function to make sure you get things in the right order. I want to pass in the time first and then the distance. And then my final step in my main program is to print out the result. Awesome. Let's compile our program and see if it works. Please enter the distance traveled. Let's say that we've traveled 60 miles and we traveled for 30 minutes. It's going to tell us the speed of travel is 2, and that's right, we're going 2 miles per minute. If we wanted to be really thorough, we should probably add some units to our code. Let's do that now. Distance traveled in miles are assumed units for the distance, and then enter the time traveled in minutes, and then our final units will be miles per minute. And we could use different units if we wanted to. If we wanted to make this hours or kilometers or something else, we could do that. That would be just fine. This is travel in miles. So let's do a different number. Let's do 100. And if we travel for 10 minutes, that's going to mean we go 10 miles per minute. That's great. Your notes have an example of the implementation so that you don't have to worry about copying down everything perfectly. Everything's in there. Notice that when I wrote it in the notes, I used slightly different variable names. That's totally okay. When you write your program, you're free to write your own version of all the identifiers. Also notice that when I wrote the version in the notes, I had the distance traveled first and then the time as the second parameter in my function. And when I did it live in this demo, I had the time first and the distance second. That's totally fine. As long as you know which number to pass in, you're going to get the correct information back from the function. So I have to know that the time is expected first in this version of the code and the distance is expected second. That will cause my algorithm to operate as expected and give the correct value as the speed. In the notes, I'd have to know that the distance traveled is the first value and the time traveled is the second value. And again, as long as I pass in the information in the right order as my arguments, I'm going to get the expected correct value back as my result. You might wonder how to know which order to place things in. Well, you'd read the documentation for the function. In this case, it's easy because we're the ones writing both the function definition and also the main program. And so you can physically see the code and know that the distance is supposed to be the first item that's passed in and the time is the second item. If this were in a non-standard library or a standard library and we didn't have access to the code, then the documentation published on the Python website would have to guide us about which value to pass in as the first piece of information and which value to pass in as the second piece of information. To summarize, if you're going to create your own function, the first thing you need to do is place the function code at the top of your file, just like we did when we wrote our calculate average speed function. You'll need to pick some parameter names to use as placeholders in your algorithm. And that's because we have no control over what information the user may pass in as these values whenever they call the function into action. They might be using variable names, they might be using literal values, and our function should work either way, no matter what information they provide. Inside the function implementation, you have to use a return statement to end the function. You either return a specific variable name or value if the function calculates something. If the function doesn't calculate anything and you simply want to note that the function should end, you just write return with no variable name after it. Once you've written your function implementation, then you're free to write the main program, and that goes at the bottom of the file. In the main program, you should include the call to your function anywhere that you want the function's statements to execute. So in this case, we wanted to calculate the average speed after we'd prompted the user for the distance and time required. You have to make sure to pass the arguments in the correct order to match the expected parameters. And finally, if there's a return value, you have to save that so that you'll be able to print it or otherwise manipulate that result in your own code.